speciality. She advises medical cannabis growers globally on how to achieve high-quality yields through optimal indoor climate and energy-efficient practices. Her knowledge of DryGair's research-backed initiatives with her in-depth understanding of the complex needs of the plants. Yanor, thank you very much.
Thank you. Hello, my name is Yanor Yazma. I'm an agronomist and I work with DryGair Energies to create innovative dehumidification solutions for closed growing facilities. I work with medical cannabis growers and growers of traditional crops, mostly in the field of environmental control. And today I'm going to be speaking about one of the most important parameters that are needed to be controlled in the growing environment, and that's humidity. There are many quality issues that we associate with cannabis. We've heard a lot of talks today about cannabinoid content. How do we ensure a consistent product for our customer and the effects that it can have, the potency. But one of the issues that we've seen taking center stage more and more these days is the issue of mold. A study was conducted in Northern California collecting products from different types of dispensaries, and they found a very alarming conclusion once these products were lab tested. 80% of the product had traces of mold or other toxins in it. Now, mold itself creates mycotoxins, which are very powerful chemicals that when inhaled, when heated, when taken in by the body, can have very adverse effects. Respiratory inflammation and infection, difficulty breathing, coughing, chest pains, and for the most part, the patients that we work with are already immunocompromised, and these can really cause a lot of problems. In some cases, we've seen the complications linked to causes of death. And this is not something that we can allow ourselves. So what we're seeing is more and more cases of product recalls because mold is found in final product. Now, this has a lot of damaging effects. First of all, for the customer, who is reliant on the product and now it's taken off the shelves until a new supply can be ready. Second of all, for the medical world, who's having a lot of problems adopting this type of medication, and these type of setbacks make it even more difficult for them to be willing to adopt and try working with this type of medication. And third of all, for the growers and the producers themselves, who are hurt not only economically, but suffer losses in terms of their reputation and the reliability of their product. Upstream, in the production side of things, we're also seeing that growers turn to more conventional, traditional tools to try and fight this off. I'm talking about pesticides. Now, pesticides are something that have a very limited period of action that we can use them in cannabis. And sometimes they are very tempting to use because the losses suffered inside of a greenhouse can be very grave, because one plant gets infected and very quickly we have infection spreading like wildfire through the greenhouse. But the pesticides that we use for traditional crops like fruits and vegetables aren't applicable for cannabis that is heated, evaporated, and taken in many times through respiratory system. So we have a problem, and we need to find a solution in order to guarantee the safety of our patients and also the longevity of the cannabis industry that first and foremost relies on the initial product. So I'll speak briefly about the type of fungal diseases that we're dealing with. The two most common ones that we hear about are botrytis, which is also called bud rot. It's a mold that's caused by a fungus that we see causes rot throughout the crop. It spreads very quickly throughout the greenhouse, and we get a gray coating of mold on the flowers. We also see powdery mildew, which is a white coating on the flowers and the plants themselves. And we've also seen reports here in Israel of a disease called Alternaria alternata, which dries the plants out, and we also see a kind of cotton-like sporulation on the buds themselves. All of these diseases have one thing in common, and that's that they need the presence of moisture in order to develop. You need some kind of wetness for the spores to begin germination. Once they germinate, they can penetrate into the different parts of the plant, infect, and then the next generation of spores is created. The cannabis flower itself is already predisposed to having problems with moisture because of its anatomy. We have a very, very dense flower, and on top of that density, we also have the presence of trichomes, which make the whole thing even more sticky. And it's kind of like putting a lot of people together in a locker room. The situation gets moist very, very quickly. We also have the presence of sugar leaves built into the bud, and these leaves are surfaces that have stomata, and these stomata are transpiring water directly into where we don't want it, right into the flower. So for disease to develop, we need 3 ingredients. First and foremost, we need a host plant. In this case, the cannabis plants, and that's what we're growing, that's what we want, that's what we need. We also need a pathogen, and that's... Hey. We also need the presence of the pathogen, and that's the spores themselves. And while we take great efforts in terms of sanitation, the truth is that there is no 100% spore-free environment. So we have to take into consideration that that's going to be there. The third thing that's necessary is the environmental conditions. So as we said, we need some type of moisture in order for all of these 3 things to come together and for disease to develop. So we know we have the host, and we know that we have the pathogen. The way that we can try and attack this issue is by controlling the environment. And by reducing that factor of the environment, we're allowing a situation where we don't have all the ingredients to coexist and disease to develop. So in the case of fungal diseases such as botrytis and powdery mildew, the things that we can focus on are humidity reduction and air circulation, which further increases the impact of that humidity reduction. Now, as we know, plants are constantly transpiring water into the air. It's part of their natural growth cycle. They use that water movement to move nutrients to the places for development, and they also use water as a cooling system for themselves, much in the same way that me and you sweat. If that humidity continues to rise, as we're most of the time growing inside closed facilities, we have a problem that it can rise to a level where we get effects like this, and that's moisture on the surface of the plants. Once we have the moisture, disease can start to develop. I get asked a lot, what's the ideal humidity for growing cannabis? And some people will say, I want 30%. Some people say 70% is good for me. And the truth is, the answer isn't really that simple. Humidity acts together with a lot of other factors inside of the growing environment. And we see that these things have a balance between themselves. Temperature, humidity, radiation levels, the stage of development of the crop, fertilization, all of these things impact each other and are very interconnected. And it's important to understand how these things work together. And one of the biggest interactions and most important ones when it comes to dealing with this is the interaction between temperature and humidity. So many of us are familiar with the term relative humidity, but I'll review it just to get us all on the same page. Relative humidity is essentially a measure of how much humidity we have in the air relative to how much could potentially be held in the air. So we can think of the air as a big sponge. If the air is warmer, it has the capacity to hold a lot of water. If the air is colder, it loses some of that capacity and the water is condensed out of the air in a liquid form. That brings us to what's called the dew point. And the dew point is that intersection of humidity and temperature where water condenses out of the air as a liquid. Essentially, that's where we reach 100% relative humidity. So this can happen when we have high humidity, and we've seen plants are always contributing to that rising humidity in the greenhouse. Or if we have also high humidity with low temperature, because as we said, the air loses the capacity to hold that, and then we get essentially dew point, which is a very common phenomenon. It's this condensation that we see on the outside of cold surfaces. So the same thing that happens here is what happens on the surfaces of the plants. And that's what we need to avoid. It's avoiding that dew point. Okay? So what can we do in order to avoid dew point? We have a few options. First of all, we can use air exchange. Very simple. You take the hot and humid air that's inside of the greenhouse and you replace it with fresh air from the outside. We have systems that can do that, ventilation, exhaust fans, things like that. But there's many disadvantages. For example, take a day like this when outside the conditions, the humidity is very high. We don't have a low source of relative humidity to push that process forward. Also on days or nights when it's cold, we have to invest energy in order to reheat the greenhouse to get it back up to optimal temperatures. Now, a lot of times when you ventilate, you have a sort of one-directional flow. One type of air is being introduced on one side, and by the time it clears out on the other side, we get a very big gradient and different pockets, different microclimates inside the greenhouse. So if you don't have proper circulation, you might have an area where you do have infection that can start to spread. And the whole thing gets even more complicated the second we work during the flowering time with the black screens closed. And in order to limit light pollution, ventilation becomes a lot more complicated. So we have other options. We can heat, because as we said, when you heat the air, we have a bigger capacity for holding moisture. There's a lot of systems that are already integrated into growing facilities that give you the power to do this. Hot water systems, perforated ducts that distribute hot air, but they cost you a lot of energy. And for a lot of the limitations that we have here is that we still need to think about the plant as the central customer here, and we can't overheat the plant out of its optimum. So sometimes heating really can't provide us with the right solution. So we go to dehumidifiers, and there's different types. One type is called desiccant-based dehumidification, and essentially it uses a chemical solution that's kind of like the little baggies that you get inside of a shoebox. It's a chemical that has the capacity to absorb moisture. It absorbs the moisture in the air, and then you need to reheat that chemical solution to evaporate the water out, and then be able to use that chemical again. Now, because you have to heat, you lose a lot of the efficiency when you use these kind of systems, and also you're introducing a chemical into your grow operation, which a lot of times requires maintenance, and if you have any kind of leakage, you can cause severe damage to your plants. So that brings us to the fourth option, and these are condensation-based dehumidifiers. For example, the DryGair systems that we work with, what they do is they circulate the air throughout the greenhouse once it's closed. They inhale that moist air onto a cold surface, and essentially what we're doing is creating dew point on the surface of the equipment. We have a cold temperature, we run a refrigerant gas through there, and it works very similar to an air conditioning system. We essentially extract that moisture from the air, and you can see here's the output. All right, so let's see a little bit about what the results of this kind of system are. You can see here a graph with two green lines. That's the relative humidity inside of the greenhouse operating the DryGair system. And outside, you see that the relative humidity is relatively high. We have 85%. So you can see that when they close the greenhouse and they close the screens around 6:30 p.m., the whole night until when they reopen them at 6:30 in the morning, we have a consistent level of 57% relative humidity. And all of that gets translated directly into liquid water, distilled water, that in the case of this night, we're able to get a large quantity of water, 520 liters of water over one night. That's what the plants are transpiring, and the equipment condenses that out. You can remineralize it and use it back into your irrigation system, for example. Here we have another set of results from a cannabis greenhouse in Europe, and they were working with two systems in two separate compartments. And you can see during the night hours when they worked with the system, they were able to keep their humidity on target between 60 to 70%. And the more important thing is they got to the end of their harvest with no sign of botrytis. And that's what it's about. That's what we're working for. We work to break the cycle of disease by targeting the environment. Now, the same grower wanted to test out to see the effectivity of the system. So we can see here that he worked with the system for a number of nights and then took 2 nights off where he operated his conventional system, which was ventilation and heating. The nights that he worked with the system, he was able to receive 70% relative humidity. But on the 2 nights using ventilation and heating, the best he could do was 90%, and that's far too close to the dew point for anybody to be comfortable with. Now, the second part of this is air circulation. And air circulation and humidity, I think we can all understand if you've ever stood in front of a fan when you're sweating, it just wicks away that moisture. So I have here images from a thermal camera of a pepper greenhouse in the Netherlands. These are big plants, 4 meters tall, that are evaporating a large amount of water. And you can see that there's a lot of variation in the temperature throughout the greenhouse. And each small pocket like this is a microclimate where we could have the conditions for dew point to form. It could be colder and more humid, and that's where infection starts. But when you work with a system that integrates air circulation with dehumidification, such as what we do with DryGair, you can see how when the system is on, all of that noise, all of that differentiation is neutralized, and we prevent those moist microclimates, which are essentially the sources of infection for the whole greenhouse. Now, as we said, humidity is part of a balance. So we saw the effects that we have on air circulation and on relative humidity reduction and how that ties into disease, but we also see there's a lot of other added benefits when you dehumidify properly. So I have here a photo of a climate control screen from a Gerber greenhouse in the Netherlands, and they were testing out two different forms of dehumidification, heating and ventilation, and the DryGair condensation-based dehumidification system. And you can see that the differences in relative humidity, we have here a difference in 10%. They set their target to 80% and were able to maintain that consistently. And this has direct effects on the vapor deficit. We see this parameter that's actually a measurement for how minerals and water is moving through the plant. So we're also contributing to the growth power. And it's not only through that, but we also see that by being able to work in a closed greenhouse, we also are able to conserve our CO2 inside, and we have double the amount of CO2 in that greenhouse. Another thing that's interesting to see here is the temperature. In both greenhouses, they were able to maintain about the same temperature, about 20.5, 21 degrees Celsius, but their heating pipe temperatures, in the heating and ventilation greenhouse, they needed to continuously heat and provide hot water at 30 degrees Celsius to do that, because their windows were open, versus the DryGair system, which was able to conserve that heat inside and thus save energy by not having to rely on heating systems. We can see that again really nicely in this graph. This is from another Gerber greenhouse that uses a double pipe system. We have two layers, one on the floor and one through the canopy themselves. So we saw in the lower pipes there was a difference of 9 degrees Celsius in the heating needs. And in the upper pipes, the heating and ventilation greenhouse needed 55 degrees Celsius water, while the one using DryGair didn't need to heat at all. And that's just another benefit of proper dehumidification. You can conserve a lot of energy, and that comes right back to the grower's pocket. So, as we said, humidity, it's one big balance. If you work with a proper dehumidification strategy, you can leverage a multitude of benefits. We see disease prevention caused by lower relative humidity. This reduces the need for pesticides, and in our case, it's already a tricky thing that we can't really rely on. We have increased air circulation, and that contributes to more growth and also a lot more uniformity throughout the growing facility. We've seen that you've been able to space your plants in higher density because you don't have that fear of microclimates where problems can occur. This has implications on nutrient